Welcome back, everyone. We're doing our last lesson of physics. The next section will be our last unit in grade 10, and it is climate change. But let's enjoy this last lesson. It's one of my favorites, and this is usually the time where we get to do the eyeball dissection. Hopefully next year you can swing by and you can watch my grade 10s do it, okay? But let's take a look at the reason how we can correlate physics to biology. And one of the main reasons why we're studying this in physics, because we can apply it to our own selves. So as usual, here's the textbook reference if you need more help. So when we talk about being able to see and light hitting our eyes is not good enough, okay? We need to actually do something with that light. And so the connection from your eye to your brain is important because the brain interprets what light bounces off of and makes it meaningful to us. Not only that, so actually the connection, I just want to highlight one thing here. The connection between the eye and the brain is this thing called an optic nerve. And if you take a look at this diagram right here, this is where the optic nerve is. So it kind of juts out behind the eye. And I won't say it's what keeps your eye in your socket because there's a lot of other things, but it's one of the things holding the eye in there, and it is then connected and it goes down into where your brain is. Okay, so the optic nerve. Okay, so the eye can focus on objects at different distances. And this is something I'm noticing these days, especially since I'm on a screen a lot. I'm not sure if you notice it, but sometimes when you're looking at a screen or even at a smaller screen like your phone, and then you go up to look at, say there's a television on, or you're going to a book, sometimes it's fuzzy for a little bit. And the reason that is because your eyes will focus on a certain font or a certain distance. And then when your face looks up, so when you look at something else, your eye has to readjust because then the distance and the size of things you're looking at are different. So that's what happens. So sometimes it's fuzzy and it's just your eye reacclimating to a new situation. Okay, same thing. Like say you're in bright light and then all of a sudden you turn the lights off and it's immediately really dark, and then your eyes kind of get used to the dark and you can see more in the dark, right? That's another thing that your eye and your brain do to they work together to acclimate. So we're going to talk a little bit about those things right now, okay? So when we talk about focusing on images, when we say about making them clear and being able to focus, that's what's happening in the front of your eye. And we'll talk about the parts that are in the front of your eye first. Everything else is a brain thing, okay? And so it happens at the back of your eye. And so we'll just sit here. Obviously, this is the front of the eye. This is the back of the eye. It's in the skull, in your skull pretty much, okay? And it's leading to the brain. Brains. Okay, not brains. We only have one brain, but you know what I mean. Brain. Okay, so front, back. Okay, so let's take a look at the differences in what you're seeing in the front of your eye. So there's the iris, which is the colored part of your eye, and the pupil, which is the dark part of your eye. And really, it's like a hole in your eye. Okay. So what you're going to see, and you've probably already noticed this in your life, that when the light is really bright, your pupil is very small because you've got to limit the amount of light getting into your eye. Okay, so the iris the iris takes over. When the light is very low and it's dark, your eyes need light to see. So the pupil expands so you can capture more light and get more information. And so obviously, some of you have been to the eye doctor and had those drops where it makes your pupil is really dilated, and dilated means big. Then when you go outside and it's bright, it's like blinding, right? So that's one thing that allows you to focus, and it allows the pupil allows different amounts of light in depending on what your situation is, where you're looking. Okay, so this is a great like pathway to look at, because this is how light travels from the outside inside to your brain, so then your brain can interpret what the heck you're seeing. Okay, so this is outside, and obviously your brain is inside, and if your brain is outside, you've got problems, right? Bigger problems than figuring out the human eye right now. So let's take a look. We're going to start with the cornea, and the cornea, let's take a look right here. The cornea is on the outside, so it's this thing right here. Okay, it's a transparent curved structure in front of the eye. Okay, so transparent, obviously, because if your cornea wasn't transparent, you would have like impeded ability to see, right? Now, because the cornea is made up of a different substance than the air, it refracts the light before it enters the eye. Okay, because light is traveling between two different media. Okay, so it bends the light. Then the aqueous humor, so let's just take a look. Aqueous means like water. And if you were to, for lack of, okay, don't get grossed out here, but if you were to have an eyeball and you squished it, some water would come out. And it comes from two different places, the aqueous humor and then the vitreous humor. Humor means liquid, right? And so this aqueous humor's there, it kind of cushions things. Then you've got the pupil, which is pretty much an opening. All right, it's a hole, an opening. It's not really a black dot. Okay, and just like I described earlier, light goes through the eye, or goes into the eye through the pupil. Okay, and the pupil's allowed to dilate to let in more or less light. Now here, almost circled the wrong thing. This is like the magic bullet here, my people. This is why we're kind of studying this. Because in your eye, there's a lens, okay? And the lens is transparent, so you can see through it, and it's a biconcave structure. So remember, biconcave looks a little something like, okay? So there's my biconcave, okay? And it's a structure in the eye, because it's a lens, so it's just like the lenses we were talking about before, that along with the cornea, because remember the cornea bends the light too, also refracts light. So light comes into the eyeball through the cornea, through this aqueous humor, the pupil lets it in, then the lens also bends the light because the lens is also a different material. Okay, think of like a contact lens. Okay, now here's the kicker. The lens is able to change shape. So the minute it changes shape, it can change the focal length. And as we know from those ray diagrams, that the minute that it changes the focal length, then you can distort or change your image. You can focus on different distances, which is important, right? But it's not instant. So you go from reading close up, something like on your phone, and then you go look far away. Your lens will have to make changes in its shape in order to focus on the difference in distances of things that you're looking at. Okay, so then we go into this thing called the vitreous humor. That's this guy right here. This is my vitreous humor. And I think, oh, there we go. Vitreous humor. All right. Then we've got the retina. Now the retina is this layer, this little light pink layer. I'm trying to write over it. There we go. A retina layers the back part of your eye. Okay, so it's a layer of cells, and it's that they cover the back part of your eye. So if you've ever heard that somebody got hit in the head and they've got a detached retina, that means like they got hit and it was a really jarring hit, and it separated that layer of cells from the back of the eyeball. Okay, but that's a problem because that's where the light should be hitting. So when the light actually gets stopped by the back of your eye, it's getting stopped by the retina. Okay? So if it's detached and it's like your layer of cells, that's the retina, is just kind of flopping around, that light won't be hitting in a consistent way. So that's why sometimes people who have detached retinas see like flashes of light, or they could have blind spots or things like that. Okay. Lastly, like I said before, the optic nerve. So you're going to see that my retina is here, my retinal layer is there, but then where the optic nerve is, there's a hole, there's no retina. Now, if light goes there, if you've ever had a blind spot in your eye, that's where the image is being hit, because there's no retinal layer there. So it's like a break, and then that's where the optic nerve is. So the optic nerve carries any information that you got from the light, from what you've seen, and it brings it to the brain so the brain can make sense of it. All right? Okay. So the distance between the retina and the lens is always the same. The cornea refracts light the same way regardless of the location of the object. It's the lens that can change shape. I think I already said that, right? So the lens can move around and change shape. So maybe it's less of a concave, and then it can turn into a convex. And what ends up happening is that it can elongate the focal length or shorten the focal length. Okay? And the way that the lens changes its shape is through these muscles in the eye. Hold on, I'm just going to move on up and let's just see. There they are. So here's a ciliary muscle, and there's another ciliary muscle right there. And it kind of like pulls it longer, or contracts or expands, right? So it pulls it like an elastic band, right? Or makes it shorter. So it just changes the shape of your lens. Okay, so you want to hope that your ciliary muscles stay functional or bad things happen. All right, so let's take a look at this picture right here. Is of a functioning normal eyeball. Okay, so say we have things that we want to look at far away. Well, what will happen is that the ciliary muscles will pull the lens and make the lens longer and therefore thinner. Okay, so that affects the focal length. If you want to look at things close up, those ciliary muscles will relax and they won't be pulling on the lens. And so the lens is shorter and thicker. Okay. And that's why it takes time, because those muscles need to expand and contract when you're focusing on things from different distances. Okay. Our eye can be compared to a camera. And like you've seen, or maybe you've noticed these things, but a camera has a lens. A lot of cameras, like really good cameras, or their lenses, because I know people can buy different lenses for different types of cameras if you have separate cameras, not just like the ones on your phone. Okay. And they have different focal lengths. So it's kind of very similar to our eyeball. Okay. So the camera has a converging lens as well that focuses on a light sensitive material. And the aperture, what an aperture is kind of like our pupil that opens and closes, but an aperture would be like a circle as well that allows light in. Okay, so if you've ever seen it on a camera, it makes it a bigger circle or a smaller circle. Now, the lenses in the cameras don't change shape. So they can move out or in, or if you're really professional and you have like a business, sometimes you'll use different lenses to achieve a different effect. Okay, so this is something that's very interesting. How we fix vision problems, because I can't remember exactly, but a lot of people have to wear glasses. A lot of people have to wear contact lenses. For the most part, there's reasons why you have vision problems. And one of the main reasons of having poor vision, where you can't see, is that your eye is not the correct shape and you were born with that. So usually, I won't say usually, a lot of the time, people who have glasses, their parents had glasses or their grandparents did. So you get it genetically because you get the shape of your eyeball from somebody in your family. Okay. Also, you could have the cornea shape being not completely correct. And for that reason, then it refracts light differently. And here's another one. If your lens, because your lens is supposed to expand and contract, right? And it should do that. But sometimes that lens loses its ability to move. A lot of times that happens because as we age, our muscles and our lenses don't do what they're supposed to do. They get harder, they're less pliable, okay? And that happens to you with most of your muscles as you age. So take good care of yourself. So as you age, a lot of people will require reading glasses. And the reason for that is because the lens isn't adapting to different focal lengths as well. Okay. So what we do to fix these problems, whether it's the eyeball that's the wrong shape or the cornea being the wrong shape, is we can fix it by putting another lens in front, which is an eyeglass, or a lens directly on top of the eyeball, which would be a contact lens, or laser surgery, which is another good option. And what they do is they actually change the shape of your cornea or the lens. Okay, so if we take a look at the different problems. So the first one we're going to talk about is myopia. Okay, and when you're myopic, that means you can see near, but you can't see far. All right. And the reason that you can see near and not far is because your eye is too long. So what ends up happening, take a look at picture A. What ends up happening is, if you'll see here, the light rays will meet before the back of the eyeball. So they're not actually making a crisp intersection at the retina. The retina is getting this thing right here, right? So see where they there's space. So that would look fuzzy. Okay? So the way you fix it is that you use a diverging lens, and that diverging lens is going to spread the light rays out, and in the end that causes right here the light rays to actually meet on the back of the eye, on the retina. Okay? So, if you're bored, I don't know if you've got much to do, take a feel of your glasses if you've got glasses at home and see if you can see a difference, feel a difference in the depth of your glasses. Okay? If you are farsighted, this one's a little less common, especially at your age, but if you're farsighted, that means you can see far, but you can't see near. This is a lot of reading glasses. Okay? The official term for that is hyperopia. And the reason for you having this is that your eye is too short. So what ends up happening, so once again, let's take a boo at figure A. Your rays are going to converge. When they hit your retina, they're not touching. They would normally intersect behind the eyeball, which is not really a thing because behind your eyeball doesn't work for us. It's going to be stopped by your eye. So the whole point is that we need to use a converging lens to bring those parallel rays closer together so they actually intersect on the retina. Okay? So then there's another thing called an astigmatism. Some of you may have this. And if you have an astigmatism, guess what? Your contact lenses are way more money. Okay? Because now it's not just your eyeball, it's your cornea that's also differently shaped. Okay? So the cornea is oval instead of being round. All right. And they have to usually people who have an astigmatism sometimes will need what's called hard contacts because they need a tight fit so the contacts don't pop off their eyes. A lot of times if you have a severe astigmatism, regular soft contacts will just pop off your eyeballs. Then the last one is presbyopia, and this is where the lenses get stiff. I was telling you, age. Okay, so your lenses don't expand and contract as easily as they used to, and so therefore they can't be manipulated by those ciliary muscles. So therefore, you can't focus as well. So a lot of times people have to use bifocals, where that helps. If you've already got one prescription, it allows your eyes to adjust to two different kind of distances. Okay? So, you know, some in the old days there'd be these lines. I remember my grandmother having these little lines. She'd have like little parts in her glasses where you could see. Now they've got what's called transitions, where they translate, they slowly, like it's like a gradient. They slowly change over time. I think they even have contacts that are bifocals now, but I'm pretty positive about that. So these are some cool videos for you to watch on these vision defects. Kind of cool. Now, LASIK eye surgery or laser eye surgery versus corrective lenses, what they do. This is a really cool thing. I'm just going to put it out here. You can watch a video on laser eye surgery. I had it done and it's very cool. And I'll just explain to you what they're doing, kind of. So what they do is they cut open a flap in your cornea. Okay, so think about it this way. They've got like this one prong that's keeping your eyelid open. You can't blink. Okay, and they use this like this little scalpel. Don't worry, it's like it's not a knife because it's like a machine. So imagine somebody in your family is like cutting meat on those microtomes. It's kind of like something like that, slicing meat really thin. Okay, well in this case, slicing your eyeball really thin. Anywho, they cut a little thin flap and it's like a door opening. And then, so they've got it open, flap it open. And then what they do is they reshape the cornea to the appropriate shape. Then they, like with a laser, okay, and you can actually smell the smell of biological matter getting singed away. Then once they're done, they take a little mini spatula and smooth the flap back over. So think of it like closing a door over your eyeball again. And then what they do is they put some antibiotic drops. And I can tell you from my experience, they tell you to keep your eyes closed for 24 hours. So they'll drug you to make you sleep. And you're not supposed to rub your eyes because think on that. That would be kind of disturbing. You might rub the flap. And then it's fixed. And immediately you should be able to see better. Sometimes there's some risks. The risks can be dry eyes, or like you get really sensitive to the light, or sometimes driving at night might be an issue. That's something I find that I'm affected by a little bit. That, when you guys are driving, you'll see like night lights. Sometimes there's a little bit of a halo effect. Things like that. So that's what laser eye surgery is. Now here are some good practice problems for you to try. I just want to highlight the eye yet again. Okay, so this is all of the different parts of the eye. Here is a chart of all of the functions of the different parts of the eyeball. And the cornea, the aqueous humor, the lens, and the vitreous humor, because don't forget, these are like watery. These are parts of the eye that are different from air, and for that reason, they can bend light differently. Okay? And I'll let you read through all of this fun stuff. I already talked about the blind spot. Okay? And I think that's it. Ooh, yeah, and here's your homework. Okay, so try these eyeball questions out. All right there. Okay, and that's it. There's also an LMS quiz for you to try. Just so you know, we are going to do 4 lessons this week because we do need to catch up and make sure we finish climate change. So we have time for us to finish the course. So this is our last physics lesson. We will be starting climate change on Thursday. Okay, so we will have a lesson on Thursday and Friday. I want you guys to take care of yourselves and don't forget to ask questions if you have any. Okay, use the discussion tool or email us on LMS. Have a great day. Bye, guys.